Hey everyone, I'm Ridhim Balaji, and I'm super excited to introduce my project for Palantir's AIP paper pilot. So as a student researcher myself, I found a lot of the times I've been super overwhelmed with the number of actual academic papers that I need to read and review for my projects, my research, and my coursework. So these research papers are super complex, and really trying to figure out how a bunch of these papers really connect together can be a really time-consuming and stressful process. And reading through these technical PDFs and trying to figure out and search for specific information can feel really impossible at times. So this struggle is what inspired me to really create PaperPilot. So let me go into what PaperPilot actually is. It's an intelligent assistant that uses AI and semantic searches to really help users quickly navigate these complex research papers. So I built this using Palantir's Foundry and AIP platform, and PaperPilot really makes it super easy to pinpoint those crucial insights in these research papers and save some really valuable time and effort, and try to find like super abstract connections that you wouldn't really think about between papers that can help answer your questions. So let's go into more of how it works. So this is just an example of one of my research papers that I used for testing. So what you do is first you upload your raw papers as a media set into Palantir's platform. And what happens next is we're able to extract info from these PDFs. So what we do is this table contains the actual PDFs that we uploaded. So we extract the references first from the PDFs, then parse the PDFs to actually get the text from them. After that, we split the pages because when we retrieve the text, it's one big array that contains a huge string of all the text. We split them based on pages, and then we reformat the table so it contains more insightful information. From that, we truncate the actual text, and that's done through a chunk extraction transform that I coded. And what this allows you to do is kind of synthesize the papers, super long papers, into much more readable formats. And from that truncation, we condense, again, the super long string into multiple different chunks that are indexed. From that, we give each chunk a unique ID, so later when we're working in creating an object for it, that we can uniquely identify them. From that, then, we create embeddings by vectorizing each chunk so we can run semantic search on them. After that, we remove duplicates, and then finally, everything is structured into a nice big table, as you can see here. So let's move on. What happens next? So this is just an example of how the fully truncated final table looks like. We have our text vector that will be used for semantic search. It's using embedding. After that, we have an ID and then the actual text, as well as the chunks that we parsed with the paper ID and the titles. So next, we created two objects in the ontology manager. So the first one is the paper object. So what the paper actually is the actual research papers that we've uploaded. I've uploaded 3 papers here, and each of those papers have their paper chunks that are parsed. So those paper chunks are then linked to the actual papers where they were parsed from using the actual paper ID, which both tables contain. So this is the actual linking, where multiple paper chunks are linked to a single paper. This allows you to figure out what paper chunks that we parsed actually came from which paper when we're running the semantic search. From this is our RAG workflow. So what this does is it employs retrieval augmented generation, which is a super powerful AI technique. And what we do is by combining semantic search with the LLMs like GPT-4, GPT-4o, when a user asks a question, PaperPilot can quickly find and retrieve relevant, concise, and accurate answer, which is then cited from which paper they got it from. It's able to relate super abstract concepts. Suppose there's some concept that is related in both papers, but you don't really understand where it comes from. It's able to understand, run a semantic search, and relate the content for you, providing that insight, and then providing you an answer at the end. So let's take a look on an example of how this actually works. So my papers are mainly about robotics and algorithmic research. So let's ask, kind of trying to combine 2 papers together, what is the main conclusion of like optimal Bezier path planning in relation to EMA filters? So these are from 2 different papers where Bezier path planning is trajectory generation algorithm, and an EMA filter is a control algorithm for basically filtering out abstract data points. So let's try this. We'll put our question in and we'll run the query. So as you can see, let's walk through what happened. So we first created our ontology into an object. Next, we ran a semantic search, kind of finding what vectors were most related to the content that we actually asked. From this, we retrieve the actual search, parsing it into text, feed it into the LLM, which then is able to answer what the relation is between the Bezier curve research paper and EMA filters. This is something that's super insightful, allowing you to basically relate 2 abstract concepts from 2 super complex research papers into a super short summary that's super easy to actually understand. So let's try one more example. Can you explain what a Ramsetti algorithm is in context to Bezier curve motion planning? Again, so Ramsetti algorithm is another motion profiling algorithm, and Bezier curves are a basically way of generating trajectories. So let's see from 2 different papers how these actually relate together. So again, we paste in the prompt and we can run this. And just like that, the LLM is able to run a semantic search, find what content relates most closely from all the papers, then create this into text, feed it into LLM, which is able to give us a full, thorough English response, which is then cited. In the end, what this allows you to do is make research not tedious, but something super exciting, something where people can go to really learn some valuable information. It makes the barrier of entry into research so much more easier. I'm super passionate about actually leveraging technology to simplify research, learning, discovery, and PaperPilot is basically a representation of my commitment to making research accessible and enjoyable. So thank you for the demo, and I'm super excited about the possibility of joining Palantir and bringing my curiosity and my love for tech to solve some really critical and complex real-world problems to really make a difference.